Hello and welcome to a new video. This is for middle school math using the Math UC Zeta curriculum. We are now on lesson 12, just moving right along. And today's lesson is about finding percents that are greater than 100%. You may have heard someone say, or you may have even said yourself, that you are giving 2,000% or some number that's bigger than 100. And so we now have talked about percents in lesson 11. And hopefully the idea of what a percent is, that it's out of 100, is something that makes sense to you. So when we think about percents that are bigger than 100, we're actually talking about something being bigger than a whole. Like, so maybe we're talking about doubling something. In that case of saying I gave 1,000%, you're saying I gave more than I actually normally give, right? Or that I normally have to give. We often use that like when we're talking about competitions or sports or things where we like push that extra amount, right? That we don't normally have that to push, but because in the moment we're excited, we can push a little extra. Okay, so finding percents greater than 100%. Let's see. A percent is just a way to write a part out of 100 that kind of makes it look a little nicer, or at least that's kind of the context I feel like we have for it these days. So last time we did something like 50%. We talked about how that's saying 50 out of 100, and then we could reduce that to change it to a fraction. We can also think about the decimal equivalent to it. We basically have three ways that we can write numbers now. We can write them as percents, fractions, or decimals if we need to. But we can extend this idea now to, okay, if that's what it means to have 50%, that we have 50 out of 100, what does it mean to have 200%? Okay, so we look at down here at the bottom, that would mean we'd have 200 over 100. And what does that simplify to be? Well, 200 over 100 simplifies to just be 2. There's a really cool trick you can do with simplifying when you have zeros at the end that on the right side, because they both have a 0, you can cancel out a 0, and you can do that for as many zeros as there is in common. So you could actually have a step in between here where you said that's 2 over 1, but then 2 over 1 just simplifies to be 2. So that's what the number equivalent of 200% would be, is 2. And like last time where we talked about how we can, to switch from percent to decimal, we can move the decimal over 2 places, and that gives us, for 50%, 0.5. The same thing works here. We're going to move it over 2 places. It's 2 places because we're talking about out of 100, which has 2 zeros. And if we do that, we get 2.00, which we could just write as 2. Now let's look at some examples. So in this one it says change each whole number to a percent by filling in the blanks. And the way the workbook, for Math UC works is they'll show you how to do it, and then they'll like gradually try to make it to where you're doing more and more of the problem. So they'll actually have the first one done for you. You can use that to model what you think you should do. And then the next one, they might have a couple of them left as blanks, and then they'll make you do more and more of it yourself. So here we have 3 equals something over 100. Well, how do we figure that out? One way is to say, I'm going to put this over 1, and I'm going to think about what does it take to go from 1 to 100. I would have to times by 100, right? Thinking about kind of like how we get common denominators. So that means that we're going to have to times the top by 100 as well. So we get 300 on top. So that's one way to do it, is to think, what does it take to get from a 1 on bottom to a 100 on bottom? And then do that to the top. The other is to think back to what we just did with the 2 and the 200%. And kind of think about it backwards and say, okay, when it was 200%, I got 2. Now I have 3, so that should be 300%. It's really important for you to be trying to think through and say, what do I think this should be, and why do I think it should be, and then to check that you are thinking of it the right way by seeing what the right answer is, because you want to reinforce doing it the right way, not doing it the wrong way, right? So let's look at 7. So we're still talking about out of 100 because we're trying to write it as percent, but now we had to fill it in. And then we want to think, okay, how do I change 7, which is really 7 over 1, into something over 100? Well, I would do 700 over 100, right? Because that simplifies to be 7. And so that means that this is 700%. Okay? Let's look at another one. This is similar to something that we were asked to do in lesson 11, where it talked about that there are some fractions and decimals that we should be memorizing or have memorized. And so if you don't have them memorized yet, this is kind of a thing where you should make the extra effort to try to memorize them. You can make some flashcards, or you can make a list of the things that you think you should have memorized, and just every now and then look at that list. We aren't necessarily, especially at this point, used to making a ton of effort to memorize in math class, but the farther we go, the more actual memorization we'll have to do versus it just seeming like it makes sense. So keep that in mind, that if you're looking at these and don't know what the answers are right away, you've got some work to do. So we are trying to change the fraction to a percent by filling in the blanks, but there are no blanks. So whoops, we'll just change them to a percent. So there's more than one way to think about this. One of the ways to think about some of these fractions is to think about equivalent coins. There is actually a $50, and to think about, well, a $50 is 50 cents. And so 1/2 would be equal to 50%. Okay, there's also a way you can think of it, since we're trying to make it be a percent, by saying, okay, I want to change it to something over 100, and to think through 2 times what gives us 100, 2 times 50. So we're going to do times 50 on top as well, and that's how we end up with 50%. And the other way would be, if you know that 1/2 is 0.5, then you change that 0.5 to a percent, if that's easier. So that's at least 3 different ways that you can think of. You need to, in your own head, be like, okay, what makes the most sense to me, and try to stick with that. Let's look at B, 2/5. I would say on this one, I like the idea of doing 5 times what gives us 100 on bottom to figure out what we need to times the top by. That is, again, if we don't have it memorized. And part of memorizing here is that you may have 1/5 memorized as a decimal or percent and not 2/5, but we can use that to help us, right? So 1/5 as a percent is 20%, because think about being a fifth of 100%. That'd be like 100 divided by 5, which is 20. So if 1/5 is 20%, how much should 2/5 be? It should be 40%. Now, the way to do that, where we're actually using kind of math to do it, equivalent fractions to do it, is to say, is actually a really similar process, just written a different way. 5 times what gives you 100? You'd fill that in with 20. So 2 times 20 is what gives us 40 on top. For 3/4, I think of quarters, that we have 3 quarters. That's actually how we say the fraction, right? We have 3 quarters, or one of the ways to say it. If we have 3 quarters, and we think about how much money that is, it's 75 cents. 3/4 is 75%. And we can think about the same thing if we had 1 quarter. That's 25 cents, so it'd be 25%. We typically won't see it written as 2 quarters because that's simplified to be a half. And then 7/10. So again, we have this where we're talking about it, we might realize, oh, 7/10, well, that would be the same as the decimal 7/10, that's like really cool in my opinion. And then we can move the decimal over and say that this is 70%. Or we could say, well, I know that 1/10 is 10%, if that's something we have memorized. So if 1/10 is 10%, and we have 7/10 instead, that would make it 70%. You got to come up with some way to make it work for you, based on how kind of your brain works and what your brain likes the most, and then stick with it. Example 3, change each mixed number to a percent by filling in the blanks. So we want to extend this idea of percents to include things that are bigger than 100%, right? And that happens from numbers like 2 or 3 or 4 or whatever. But what if we don't just have 2? What if we have 2 and we have a fraction with it? So it's kind of like we're thinking of these separately at first, that 2 as a fraction over 100 would change into 200 over 100. So that would be our first step. And then the 1/5, we would say, well, how does that change to something over 100? So just like we did a second ago, we'd think, oh, 5 times 20 is 100. So on the top, 1 times 20 is 20. And then to add these fractions together, 200 over 100 plus 20 over 100, they have common denominators, so together they make 220. And the reason we picked to make these be over 100 was because now we can say, oh, that means this is the same as 220%. And that's our answer. So there might be a couple different ways that you could go about getting that 220%, but that's the way that we're kind of being guided through by the Math UC curriculum. So on B here, we've got 4, which we're going to change into something over 100. So to kind of go through this in a little more detail, if we want it to be over 100 and right now it's over 1, we have to times by 100. So that's going to give us 400. It may be that at first you're having to think about that every time, but eventually, hopefully, you just automatically think, oh, 4 is 400%, right? 1/2 as a percent is 50, so we'd put a 50 on top here. That's one way of thinking of this. So together, this would be 450 over 100, which is 450%. Okay? Example 4. Now let's change percents to a decimal, and this is one of the easy things to do, but does require, again, us possibly memorizing, because we can go through this by going like, okay, it's 315 over 100, and then changing that to a decimal. But remember our trick from before, that we can just move the decimal 2 places whenever it's a percent, and that gives us what this is as a decimal number. And we can use that to just really quickly get the answer if we remember that that's how it works. So if we don't remember that and we go the route of saying 315 over 100, well, then we're thinking, how do I divide 315 by 100? What does that do to 315? And essentially what it does is it moves the decimal to the left 2 places. That's why that's the rule that's happening. So yeah, hopefully you memorize the rule there. So for B, 108, we just want to move the decimal over 2 places. So this would be 1.08. Now we probably see percents all over the place. Like if you think about things being on sale, they often have percents attached to them. When we do things like calculate taxes or tips, we have percents attached to them. This is actually a similar problem to what we saw last lesson, where we calculated either tax or the tip or both. But now we're going to learn that there is a little bit easier way to do it if we use the idea of percents greater than 100. Because in this situation, we've got a meal that's costing us $24.50. So that's the meal. But then we're going to calculate a tip, and we're going to calculate tax. But here's the thing. We have to pay for the meal, right? The $24.50. We have to pay for 100% of that meal, right? Because we have to pay for the whole meal. When you are starting with some amount and then applying a percent to it, you can say, well, I'm starting with 100%, because I'm not going to pay 80% of the meal. I'm going to pay 100% of the meal. I'm not going to pay 200%. I'm not going to pay double. I'm paying, at the very least, I'm paying for 100% of the meal. And then we can say, well, what happens whenever I add to that tip and a tax? The tip is 15%, and the tax is 10%. So what we can do here is we can say, well, if I have these different percents, I can add them together and get 100. We might have to go over to the side, right, to add these vertically, because that's a little easier. So, but we get 125%. So that's how much we're actually paying for the meal, is that $24.50. We're going to pay 125% of that for our meal, tip, and tax. So we actually, if we realize that we can do that, can actually do less multiplication and addition, or easier multiplication and addition than we did before. Although this next part is a little tricky. If I want to multiply $24.50 by 125%, we first have to change it to a decimal. So that's 1.25. And then whenever we multiply these together, it would actually be easier multiplication if we don't put the 0 on the end of the 2450 and do, and basically we've got a 3-digit times a 3-digit number, which is kind of annoying, and it's going to take a little while, and it's going to be easy to make some mistakes here. So try to take note, if you do make a mistake, on what is causing that mistake. Is it a multiplication issue? Is it a decimal issue? Do you need to just write more neatly so that you can read your own handwriting? And try to improve whatever the problem is. So 5 times 5 is 25. Carry our 2. 5 times 4 is 20, plus 2 is 22. 5 times 2 is 10, plus 2 is 12. And then I'm going to mark these out so I don't accidentally use them again. I'm going to put a 0 here as a placeholder. 2 times 5 is 10. 2 times 4 is 8, plus 1 is 9. 2 times 2 is 4. Now we've got 2 placeholders. Then I'm going to mark this out. And I'm going to do 1 times each of these. So 5, 4, 2, and add coming down 5, 2. Let's see. 2 plus 9 is 11, plus 5 is 16. 4 plus 4 is 8, 9, 10. And 3. Now, how many decimal places do we need for this? We've got 1 decimal here, and we've got 2 decimals here. So our answer needs 3 decimals. So that means it's going to be between the 0 and the 6. The other thing, though, is we have to round up to the nearest cent, because you wouldn't hand somebody $30.62.5. That's not something you'd do. We'd round this up so that we have 30.63. Now, if you're thinking back to last lesson, we did a similar problem, but a different way. We calculated like 15% of the meal, and then we calculated 10% of the meal, and then we would have taken those values and added it to the cost of the meal. That's a perfectly legit way to do it, and there's nothing wrong with doing it that way. But if we get the hang of doing it this way, it saves us at least one set of multiplication that we'd have to do, and also saves us, makes our adding a little bit easier as well. So, one more example, and honestly, this was partially just to be funny. So, a completely made-up situation, I assure you. This random person named Mrs. Stevenson, I don't know them personally, offers Jaden, which is her son, a 300% raise on his allowance if he will start doing all the laundry. If his current allowance is $1, what would his new allowance be? Now, my child's 3.5. He doesn't get an allowance because, I mean, I don't even know if he will get an allowance someday. And I apologize if this just makes you think, man, I wish I had an allowance for doing laundry. You should do chores that your parents ask you to do because they ask you to do them. But let's just go with this anyway. So his current allowance, his current made-up allowance is $1. This whole problem is made up. None of it's real. His current allowance is $1. If we are raising that by 300%, we need to times by 300%. Okay? But we can't do that with this being 300%. We need to do it with a decimal. So what's 300% as a decimal number? There won't be a decimal place, right? But any number that is not a percent or a fraction is in decimal notation. So keep that in mind. So we change this by moving the decimal over 2 places and have 1 times 3. So his raise is now he's going to make $3. So to do all the laundry, not just some of it, all laundry all the time. Wishful thinking, I think, on my part, because he is 3.5 and not likely to do laundry, but it is what it is. Thanks so much for watching. I hope you enjoyed the video. If you did, there's a really cool way you can show me you liked it, and that's by pressing that thumbs up button. A less helpful thing you could do is press the thumbs down button, because that would mean that you didn't like the video or that you don't like me, and that would make me sad. But it's okay. Whatever. Subscribe if you haven't already, and I'll see you in the next video.